unit circle that is wonderful is that if you know sine and cosine, you are in great shape. You can find the other three. If you don't know sine and cosine, though, you're a little bit tough. So you want to make sure you've got sine and cosine on lockdown. I'm going to show you some hints for tangent as well, which are going to make tangent pretty easy. Tangent, when in doubt, tangent is sine divided by cosine. Always and forever. Sine divided by cosine. Which makes it, again, it's just based on those two values that you're getting to know so well. The rest of them, cotangent is cosine over sine or 1 over tangent. Sometimes it seems like that you're going to have extra work to do here. Practically, cotangent, you take tangent and you flip it. You just want to have this little okay. Kind of blank spot. Sorry. I don't know, bottom of the unit circle maybe. Sorry about that. You're going to take sine and flip it. Don't worry, we'll do so many. We'll do so many. Cosecant, you're going to take sine and flip it. Secant, you're going to flip cosine. Sorry, I either needed to put variables in there or actually do the words. Practically, when I'm doing a problem where I'm doing all 6, which we're going to do here in a minute, I will find tangent, and then I will write cosecant right next to sine, and just flip the fraction. I will write secant right across from cosine, and flip the fraction. I will write cotangent right next to tangent, and flip the fraction. If unit circle isn't something that you have on lockdown and it's something that you it's going to take you some time and effort to memorize, I'm going to tell you right now, we are going to be using it so much that you will be happy. Like the sooner you know it, the happier you will be. Right? The sooner you've got it down, the happier you will be. All right, sorry I didn't have that diagram. We're going to use it. I think what's helpful for tangent is if we do a little free work, I don't know, on the bottom of your unit circle maybe, or on the back of your unit circle, or on a blank piece of paper, and just do tangent of all of our first quadrant stuff. Do tangent of all of our first quadrant angles, and then we'll be in good shape.
Still unit circle today.
Unit circle day 2. Unit circle forever. I think I made a test for them for like January, and the first 9 questions are just first quadrant of the unit circle, and it says unit circle, it's dot, dot, dot. Always is forever. Yes. Okay, so tangent. Tangent is sine over cosine. So I'm going to do this. If you want to just be a sponge and absorb, that's fine. If you want to write this, like our final values here on the side of the unit circle, you can, like along, wherever you want. Find a spot, not on the like page with the problems on it, because you're going to need the room there. Separate sheet of paper. Back of the unit circle. I think there's a blank back of something in your pocket somewhere. All right, so tangent is sine over cosine. I'm just going to use x as our variable for now. Just putting that up there so you know where we're getting these values. Again, if you need to, I had people in other classes yesterday very resistant to unstapling their unit circle, but it's a really good thing to have in front of you if you need it. So at 0, what is sine? So here's our angle, and I'm going to get our value. I'm going to do sine of 0 over cosine of 0 to get tangent. So what is sine at 0? Yeah, 0. And what's cosine of 0? Positive 1. And 0 over 1 is 0. So tangent of 0 is 0. That's one that I don't particularly have memorized. I write it out every time. I can do it fast enough that way that I'm happy with that. Okay, now I'm going to do sine of pi over 6 over cosine of pi over 6. All right, what is sine of pi over 6? Yeah, 1/2. It's your little angle. All right. What, do you want me to do division like side by side with the fractions? Is that what you would prefer? Okay, I saw a couple yeses, so I'll do it that way instead of stacking it. If you want to stack them, I love that as well. Okay, if sine's 1/2, what's cosine? Radical 3 over 2. Okay, so I'm going to flip the second. My 2's cancel. This is why radicals were on your entrance exam. If you were like, why do they have radicals on the entrance exam? We haven't seen them in forever. Here they are. This isn't how we leave things. In AP Calculus, you can leave it like this. You'll love that about AP Calc. You don't have to rationalize denominators. And here you do. So how do I rationalize this denominator? Right, just multiply the radical up. So this is radical 3 over 3. Sorry, I used so much space. Yeah, the 2's cancel there. So you have 2 over 2, which is just 1. Okay, so there. Tangent of pi over 6, all the way over there is radical 3 over 3. I'm going to give you a quick way to memorize that in a second once we get all of it. Okay. Tangent at pi over 4 is the same as sine of pi over 4 divided by cosine of pi over 4. What is sine of pi over 4? I need somebody to say it really quietly. Might as well say it. I can hear you at powerful ears. What's cosine of pi over 4? Radical 2 over 2. And anything divided by itself is 1. All right. Tangent of pi over 3 is the same as sine of pi over 3 divided by cosine of pi over 3. This one is a little less painful than that one because we're not going to have to rationalize the denominator. Sine of pi over 3 is radical 3 over 2. Cosine of pi over 3 is 1/2. Flip the second. Flip that 2 up. That makes me happy because my 2's cancel. And you just get radical 3. Last one we're going to do, because then these are just going to repeat around the unit circle like sine and cosine do, right? If they're based on sine and cosine, that has to happen. So sine of pi over 2 over cosine of pi over 2. Sine of pi over 2 is 1. Cosine is 0. Can we divide it by 0? Let's pretend that you're saying no. No, because it gives me an infinite. I like to have easy ways to remember things. I don't particularly have an easy way for 0 and pi over 2. I just write them out. I know sine is 1, cosine is 0, and I write it whichever order it needs to be, and get 0 or undefined. I do have these middle 3 memorized. And here is how I have these middle 3 memorized. There are things in this class that I had memorized, like I know that in the middle of the night at 1 o'clock in the morning you could ask me and I would know it. There are things that I memorized within the unit. I have this memorized cold, like in the middle of the night cold, because of this. 6 is 3 plus 3. That works for me. 3 matches with the 3 under the radical. That is what works for me for those two. I know for pi over 4, sine and cosine are the same, and since I'm dividing them, that's going to give me 1. That works for any 6th, any 4th, any 3rd. All of the thirds around the unit circle are either positive or negative radical 3 for tangent. All of the fourths around the unit circle are either 1 or negative 1. All of the sixths around the unit circle are either positive or negative radical 3 over 3. And you can just do that all students take calculus thing that we talked about yesterday to figure out, based on the quadrant you're in, whether you have negative or positive. Okay. So if you want like what to memorize, really it's just that, and that, these 3 in the middle, and know how to get basically this part of it is what I write that middle stuff on those every time because I freak my leg. I'm like, I know it's 0 or undefined. Where's that 0 go? Top or bottom? Okay. If it's helpful to you, you can later, when we have some time, go around the unit circle and put tangent values in, like off to the side. If it would be helpful for you to like make yourself a little tangent column over here, tangent of pi over 6 is radical 3 over 3, you can absolutely do that. Tangent of pi over 4 is 1. Tangent of pi over 3 is radical 3. Because now when we add those to the problems that we've been working on, the problems that we started yesterday, you're just going to be adding in tangent and then flipping all the fractions to get cosecant, secant, and cosine. Okay? Again, everything is positive in quadrant 1. Sine is positive in quadrant 2. That means tangent is negative there. Tangent is positive in quadrant 3, and cosine is positive in quadrant 2. Right? So let's get to those problems. You do have this in your packet. Let's get to this problem where we're doing all 3 and build on what we had yesterday. Yesterday when I was writing these out, I wrote sine and then cosine. I'm really in that habit because the tangent is sine divided by cosine in that order. It's kind of what works for my brain. If you want to write cosine and then sine, that's fine. I'm going to go ahead and write tangent right below here though. And I like to work with tangent the same way I work with sine and cosine, in that I'm just going to look at the pi over 3 part, and it's going to tell me what my little ratio is. So what is tangent of pi? All the pi over 3's. Radical 3, yep. And all the pi over 3's, tangent is radical 3. Now, 2 pi over 3, we said it was quadrant 2. Is tangent positive or negative there? All students, so sine is positive there. And if we're doing a division to get to here, we have positive divided by a negative, it's a negative. So there's your tangent value for 2 pi over 3. Yeah.
So, like, if we're not really understanding the all students, are you saying the side, every side besides the side in that section is negative?
Yeah, so when we do, so all are positive in quadrant 1. Sine is positive in quadrant 2 because it's the y value, right? Y's are positive and x's are negative there. Sine and cosecant are going to go together. So whatever SIGN sine is, cosecant is going to be as well. Our tangent is positive in quadrant 3, so tangent and its pair, cotangent, are going to be positive down there. And cosine is positive in quadrant 4, and cosine is going to go with secant. So this mnemonic, like all students take calculus, is a little misleading because the pair is going to go with it too. And if we're just looking at this and flipping this, we're going to take that positive or negative. Okay, that's tangent. Let's do the other 3 because they go right with it. Cosecant is 1 over sine. It's sine's reciprocal, not its inverse. And it's a funny thing. And I had to think through which word to use really particularly because sine does have an inverse and it's not cosecant. But cosecant is literally sine's reciprocal. We just flip it and rationalize. So if sine is radical 3 over 2, cosecant is 2 over radical 3. Somebody wants to ask me right now if I'm sure that cosecant goes with sine because it seems like it should go with cosine. It goes with sine. I don't know why. It's a naming convention. I don't know. I'm sorry about it. I want it to go with cosine too, which is so when I rationalize here, I just bring that radical 3 up, and cosecant of 2 pi over 3 is 2 radical 3 over 3. That's cosecant. Cosecant is sine's reciprocal. Smartboard is not beating my mind right now. Cosine's reciprocal is secant. Its little abbreviation is SEC. Oh, by the way, these don't mean anything if you just write SEC and then not the angle in there. You gotta have an angle in there, or you can write X. You gotta have something in there. So to find secant, secant is by definition cosine's reciprocal. So we're gonna flip it, we're gonna keep any positive or negative that's there. So when I flip negative 1/2, I get negative 2. If you want to write negative 2 over 1 to kind of preserve that relationship for yourself, that's lovely. This one makes, at least it, like the naming convention makes sense. Tangent's reciprocal is cotangent. The abbreviation is COT. And when we flip this is negative radical 3 over 1. So when we flip it, that 1 is going to flip up. And then we're going to rationalize. Negative radical 3 over 3. Yeah.
So, is cotangent like cosine over tangent?
Cotangent is cosine divided by sine. Yeah, that is one way that you can find cotangent. We will be so good at all of the ways that these are related. But yes, cotangent is cosine over sine, just like tangent is sine over cosine. Again, the specific definition for cosine or for secant is 1 over cosine. The practical definition is flipping. That's what happens when you put a fraction at the bottom. Is flipping. Same thing for sine and cosecant. And I can make little copies of that little business for you. You'll get them in the next unit as well, because we will use these. Like I said, always interrupt. Yeah. Okay. All right. Questions? Yeah.
Yeah, can you go back to the other page for the
Tangent values?
the one with all the different, yeah, that, yeah. That one makes sense.
All right. If you're done with number 1 and you don't want to write these down at this moment, because I'll make a copy of that for you. I'm sorry I didn't put it in your packet. Try, what's the next one? 7 pi over 6. You can start with getting a tangent value for 7 pi over 6, or you can just flip your sines and cosines and wait for me to explain them. Yeah. Cotangent and all the pi over 3 is radical. Yeah, radical 3 over 4. Tangent is just radical 3 over 4. And then when you flip it, that one goes to the top. So you meant that. Yep. Flip that square. There's some clauses. This guy's negative, but there's nothing to go back there. The negatives and positives stay the same. Well, no, you bring the radical, it's a radical 3, radical 3, and then it's radical 3 over 3. You did. This was radical 3 over 1, so now this is 1 over radical 3. And then. Yeah, I got one. Okay. There's a video of me. There are a couple of videos of me. It's good. Ready for the next example? All right. So yesterday we did 7 pi over 6. We found that sine of 7 pi over 6 was negative 1/2. And cosine of 7 pi over 6 was negative radical 3 over 2. Let's get cosecant and secant first. Cosecant, we're going to find cosecant of 7 pi over 6, we're going to flip sine. So what's negative 1/2 flipped? Negative 2, absolutely. And if you want to write negative 2 over 1, again, to preserve that fraction, for your eyeballs, that's lovely. I like it. Cosine's reciprocal is secant. So I'm going to flip the negative radical 3 over 2. So I'm going to flip it so it's going to become negative 2 over radical 3. And then we're going to rationalize. So I'm going to bring that radical 3 up. When you do all 6 of these, sine, cosine, tangent, and their reciprocals, every one of the problems is going to look like this. Most of them are going to have, your 1/2s and radical 3 over 2s, and it's nasty when you flip radical 3 over 2. But 1/2 kind of makes up for it. Kind of a nice one. All right, let's talk about tangent and cotangent. All right, tangent of 7 pi over 6. all the pi over 6's, tangent is radical 3 over 3. And remember, the little 6 is 3 plus 3, and that's how I remember that. 7 pi over 6 is in quadrant 3. In quadrant 3, that's where our x is negative and our y is negative. Since tangent is those two divided by each other, tangent is positive. And I kind of can't help myself, so I'm going to put positive. So tangent at 7 pi over 6 is positive radical 3 over 3. Again, if you don't want to memorize, you can divide every time. Negative 1/2 divided by negative radical 3 over 2 is going to give you positive radical 3 over 3. You can divide to find tangent if you want. I prefer not to do that division over and over again if I can figure out a way to memorize it. Okay, cotangent is tangent flipped. I'm going to write it below because we're going to have some rationalizing to do. So I'm going to flip that bad boy. So it was radical 3 over 3. Now it's going to be 3 over radical 3. And this problem is going to have 100 3's in it. We have to rationalize again. So I'm going to multiply the top and bottom by radical 3. So the top is going to be 3 radical 3. The bottom, when I have radical 3 times radical 3, what happens? Yeah, it's just 3. If it helps you to think of that as, oh, that's square root of 9, square root of 9 is 3, that's fine as well. However you process that. And then you end up with a 3 on the top and a 3 on the bottom, so that is just radical 3. On the last problem, when we started with tangent was radical 3 and flipped it, we got radical 3 over 3. The same thing happens here. That's always going to be the relationship. Again, these repeat. There's a very, very, very finite number of questions that I can ask you on the unit circle. You're probably going to get through all of the iterations in the next couple of days. Questions about this one? Okay, let's do a pi over 4. Oh, the reciprocals of these are a little painful here, but that's okay. I'm going to make these guys smaller so we have some room. The nice thing about finding cosecant and secant for any of the pi over 4s is once you do it for sine, you've done it for cosine as well, since they have the same value. So I'm going to, again, just flip these guys. Cosecant of 7 pi over 4, we're going to flip sine. So I'm going to have negative, 2 comes up, radical 2 goes down. And then you're going to rationalize. So I'm going to multiply here the top and bottom by radical 2. It's going to feel very similar to that problem with all of the 3s that we just did. Oh, and I just wrote a 3 because I was thinking about all of the 3s. On top I have negative 2 radical 2. What happens on the bottom? Radical 2 times radical 2? Just 2. And then those 2's cancel. So I end up with just negative radical 2. That is cosecant of 7 pi over 4. Secant of 7 pi over 4. You're welcome to do that math again. Or you can say to yourself, hey, I just did that for this other radical 2 over 2, so this one's going to be positive because cosine's positive. Again, the sines, SAG and S, are going to follow sine and cosine and tangent. They're going to be the same for the reciprocal. So all you're doing is flipping it. Okay, tangent. I like all the pi over 4s for tangent in particular. What is tangent and all the pi over 4s? If sine and cosine are the same number, what's there when you divide them? What happens? You get 1. Now sine is negative and cosine is positive, so tangent's going to be negative. Negative divided by a positive is negative. And then cotangent, what happens when we flip -1? What do you get? -1. All right. What I would like you guys to do right now is find the problems on the practice. So you're going to flip twice. Find the problems on the practice that look like this. They're the all 6. So they're like right on the bottom. So you're just flipping once like this. Right on the bottom here where you have 5 pi over 3, 5 pi over 6, 3 pi over 2, and 3 pi over 4. And try those guys and I will put answers up. So try those 4. So on that first practice, that's good information. So 7 is 5 pi over 3. Yep, just the back of that. Try those